Hello everyone. We have a question of a modulus inequality, and the question is regarding solve the inequality and a modulus sine 3x minus a greater than 2 times modulus sine with x plus 2a, where a is a positive constant. Because we have an inequality and we have to solve it, definitely solving means finding the value of the variable, which is basically x, because a is a constant as per question statement. We have to find the value of x because it is an inequality, so definitely the answer would be the set of values of x. The process is very simple. Simply square both sides, and instead of modulus sign, just use the round bracket and square both the side, and by squaring apply the formula of a minus b whole square, which would be a square minus 2ab plus b square. On this side 2 square is 4, and apply the formula of a plus b whole square, and that would be a square plus 2ab plus b square. And after that, getting the value of a square plus 2ab plus b square, simply multiply this 4 with the bracket, and after that just move all of them on this side and arrange the like terms together. That means the x squared term with x squared term, the x term with x term, and a constant with constant, and then simplify them. And after simplification we have a proper quadratic equation, which is 5x square minus 22ax and minus and a constant. The condition is it is greater than 0. So first of all, get the values, the critical values. In other words, get the x intercepts, because the x-intercept definitely would decide the set of values. For finding the x-intercept, because the condition over here is greater than 0, this 0 is basically representing the value of y, or the function, I would say. So we know that when y is 0, definitely the x lies on the x-axis, and definitely it is an x-intercept. So use the quadratic formula, get and use the value of a as 5, the value of b as negative 22a, the value of c as minus 15a square. Place them in the quadratic equation, simplify them, and after simplification we have the two critical values, which is 5a and minus 3 upon 5a. Draw the graph for this because it was a quadratic equation, so definitely if we draw the graph of this, it would be a curve, a symmetrical curve, and the coefficient of x square is 5. That means it is positive 5. That means the curve would be a u-shaped curve. We have two values of x, a positive value 5a and a negative value minus 3 upon 5a, and we have 5a over here and minus 3a upon 5. Finally, the condition is that it is greater than 0. As I said, this 0 is basically representing the value of y, or the fx, and it is greater than 0 means positive. And if it is positive means positive y. And when it is positive y, we need the values of x which would result in a positive value of y. If we just observe the graph, we can say that if we take any value greater than 5a, and if we take a point and draw a graph on this particular curve, we can say that definitely the y would be positive. That means for any value greater than 5a would result in a positive value of y, or any value less than minus 3 upon 5a will also result in a positive value of y, because if we just take any point and draw a graph for that, draw a particular point on the graph, and we just check out the value of y, it would be positive. So finally we can say that the set of values for this particular given modulus inequality will be all the values greater than 5a, as mentioned over here, x is greater than 5a, and all the values less than minus 3 upon 5a, as over here we have mentioned, would be the solution for the given modulus inequality. In other words, the set of values for the given condition.